In a previous lesson, you learned how to connect a DC motor to the Arduino using a transistor. The way the transistor works is it's an electronic switch. In the diagram, you can see that leg C of the transistor is connected to a power source. Leg E is connected to the DC motor. When this circuit is closed, the DC motor will turn. When it's open, the DC motor will be off. Leg B is controlled by the Arduino. This is the leg that acts like a gate. It will either open or close the circuit. So you have to write in your code when you want leg B, which is controlled by a pin, to be closed. The transistor only allows the current to flow in one direction. For this reason, you can only use a transistor if you want the DC motor to turn in one direction. If you want it to turn in more than one direction, you will need to use what is called an H-bridge. Here you can see a clip of a DC motor turning in two different directions, clockwise and then counterclockwise, by being hooked up to an H-bridge chip. Notice that there are quite a few wires connecting the H-bridge chip to the Arduino board. You may be wondering, what is an H-bridge? An H-bridge is a circuit consisting of 4 separate transistors that are hooked together to one motor. In the diagram, you can see that 2 of the transistors must be closed, while 2 of the transistors must be open to allow the current to flow in a specific direction. On the left-hand side, S2 and S3 are closed. This allows the current to flow left and allows the motor to turn. In the diagram on the right, S1 and S4 are closed. This allows the current to flow in the opposite direction, switching the direction of the motor. Here you can see the code for the H-bridge chip. You will need a lot of different pins that are connected to the Arduino board. The actual code is quite simple. Certain pins will be turned high while other pins are turned low. Most Hbridge chips can handle more than one motor. In the previous clip, I only showed the wires necessary for controlling one DC motor to turn forward and backward. But what if you want 2 motors, such as in a small electronic car? The Hbridge driver will still work for this. However, there will be a lot more wires involved. And as you can see, it can get very tedious and confusing hooking up all the wires correctly. So instead of using the chip on a breadboard, what you can do is purchase a separate Hbridge driver that has all of the components connected on a single board. A lot fewer wires will be necessary to hook this up. Here you can see an L298N driver board. On the left and right sides are the ports for the motors. You plug one motor into the A and B ports and then another motor into the C and D ports. At the bottom you can see VCC, ground, and 5 volts. 5 volts needs to be plugged into the Arduino board, and the VCC and ground are plugged into your power source. In my car demonstration, I will be using a battery pack as my power source. I ended up needing 9 volts to be able to power the 2 motors. I plugged the 9 volts directly into the Arduino board and then used the VCC to connect to the VIN port of the Arduino to get the full 9 volts instead of the regular 5 volt output that the Arduino usually has on its output pins. To control the motor driver, you also need to plug 4 digital pins into the motor driver at the NA, NB, NC, and ND terminal pins. Once you've plugged them in, write your code so that the A and B are high and low at the appropriate times, and the C and D are also high and low at the appropriate times. When using the Hbridge driver, hooking up the motors is the most complicated part. After that, the coding is easy. Each of the motor pins has to be connected to a digital pin. Please make sure that all digital pins are designated as output under the void setup. After that, I used subroutines to designate the motion. I have my car moving forward, stopping for 100 milliseconds, then moving left, stopping, moving right, stopping, and finally moving backward. The reason I put in the delays for the don't move is because unfortunately when the motor stops for only a very short amount of time, the motor might keep spinning even though the electric current has been turned off from the digital pin, and this can wear down your motors. So I did put a don't move routine in there to stop that from happening. Here are my subroutines. For don't move, all the motor pins are low. For backward, motor A and motor C are high. For forward, the opposite, motor B and motor D are high. For left, only motor B is high, and for right, only motor D is high.